Hello, welcome to this G12 revision video. I'm PVS the tutor. Now, in this video, we are going to look at this is chemistry, by the way. We are going to look at organization, characteristics of states of matter. Now, at our actual level, we know that we have three states of matter: that is solid, liquid, and gas. Now, I'll branch this by explaining one by one. A solid, the characteristics of the solid is that it has got a fixed volume. It has got a fixed volume and shape. They can explain why it has got a fixed volume and it has got a fixed shape. The particles are closely packed together. So when the particles are closely packed together, they don't move, they only vibrate. So because the particles are firmly held by strong internal electrostatic force of attraction, the particles make a shape which is very fixed, and the volume becomes fixed too. By saying to change the shape of the solid, it requires force, such as when it is broken or cut down with an instrument. The particles, this is it. When they tell you to draw the arrangement of particles in a solid, this is how you draw them: closely packed. And like I said, the particles don't move, they vibrate. In a solid, the particles do what? Vibrate about a fixed position. They vibrate about a fixed position. That's how the particles move. Examples are stone, ice block, and etc. A liquid has fixed volume but no fixed shape. Why? Because it can take the shape of any container. It can flow. It's a fluid. A liquid is an example of a fluid. This one that it can flow. A fluid is something that can flow. Now, because it can flow, that means it can occupy any container available. So the shape cannot be fixed because it takes the shape of the container, but the volume will be fixed. If it's 20 cubic centimeters, it will be 20 cubic centimeters. But when you transfer it to another container, it has to occupy the shape of that container. When you are told to draw the arrangement of particles in a liquid, they should be in a disorderly. This is disorderly arrangement. Okay. Examples of liquids: water, paraffin, cooking oil. So the particles must be disarranged in that order, not the real order, but in a disorderly way. The same way they have been drawn. In a gas, the gas has no fixed shape and no fixed volume. A gas will expand to take the full volume of the container it is in. And when you are told to draw the arrangement of particles in a gas, you draw those particles, but you show arrows. These arrows indicate the movement, how they are moving. Last part we are going to look is a change of states of matter. Now, we have a lot of changes of states of matter, but in this case we're going to focus on this. The first one is solid to liquid. So we have solid to liquid. Solid to liquid. This is what we call melting. Now, when a solid is heated, okay, particles begin to create space. And once they begin to create spaces, they become in a disorderly way, forming a liquid. Then liquid to solid. That's what we call freezing. Let's say you put water in a fridge as a liquid. At some point, you discover that it has formed an ice, and then that's now I'll be explaining what type of process are these. What type of process is melting? Melting is endothermic process. Freezing is exothermic process. The other one is liquid to gas. Liquid to gas is what we call boiling or evaporation. What type of process is this? This is endothermic process. Then we have gas to liquid. Gas to liquid is what we call condensation, and this is exothermic process. And we have sublimation. We have solid to gas, which is sublimation. Okay. Solid to gas sublimation is also endothermic process. Then the last part we have is gas to solid. It's also sublimation, but I would rather use deposition, which is exothermic process. All right, so that's what we had for you. We wish that you join our online classes. I'll see you in the next video.